plus H2SO4 plus H2C2O4. Okay, now this forms K2SO4 plus Cr2SO4 3 times plus H2O plus CO2. The question given to me is to balance this particular equation. Okay, so like I told you yesterday, your points where you have to look at is you have to look at this particular species, then you have to look at this particular species. Okay, so if I look at the oxidation state of chromium, so O7, 7 into minus 2 is minus 14. Potassium, there are 2 potassium, so totally plus 2. So the total charge on the 2 chromiums is equal to plus 12. So each chromium is 6. So I have Cr in the plus 6 state becoming Cr to the plus 3 state. Here chromium is in the plus 3 state, here the chromium is in the plus 6 state. On the right hand side chromium is in the plus 3 state, on the left hand side chromium is in the plus 6 state. So what must be happening is it must be taking in 3 electrons. Yeah, but I see there are 2 chromiums. So if the 2 chromiums have to be there, there have to be 2 chromiums here and there have to be 6 electrons. Yeah, so I know what chromium has done. Now let me look at C2O4. Okay, so C2O4, we can look at C2O4 species itself or we can look at carbon. So this is in the minus 8, totally 4 oxygens are there, each minus 2 plus 2, so it is plus 3. So there are 2 carbons which are in the plus 3 state and it is becoming carbon in the plus 4 state. This can happen definitely by giving 2 electrons, because there is C2 here, I put 2C here. Okay, so now there are 2 electrons, but here 6 electrons are being given, so there has to be 3 electrons here, 3 of these taking place. Yeah, so now I am good to balance. So now this is fine, this is fine, so there should be 3 of them here, so 3 of them here. Because there are 3 of them, totally 6, so 6 of them here. Now potassium is balanced, chromium is balanced. Next let me balance sulfur. So there is 3 plus 1, 4. So I balance sulfur. After that let me balance hydrogen. 4 into 2, 8, 3 into 2, 6, totally 14. So I put 7. Now this is a balanced chemical equation. Yeah. So are you able to understand this? Okay, so yes, so other friends of mine who are there in the class, please quickly get back to this and then see if we are able to understand this. First, I tried to find out the oxidation state of chromium on the left side and on the right side. Again, I am telling in 90% of our cases, as far as chromium is concerned, it will be going from plus 6 to plus 3 state. It will be going from plus 6 to plus 3 state. So 90% it will be going from plus 6 to plus 3 state. Yeah. Then carbon on the left side is in the plus 3 state, it is going to carbon in the plus 4 state. So in one case it is giving electrons, in one case it is taking electrons. So I am ensuring that the total number of electrons given is equal to the electrons taken. Number of electrons taken equals number of electrons given. No, I am not your chemistry teacher. Sir will be back. Sir has some difficulty, so he will be back. How oxygen? I don't understand. Why did I multiply with 3? I multiplied with 3 because if I don't multiply with 3, 2 carbons are giving 2 electrons. So 2 electrons have been given, but 6 electrons have been taken. So I can't see how somebody can give 2 electrons, but I can take 6 electrons. Not possible. So only if somebody gives me 6, I can take 6. So carbon has to give 6. To make carbon give 6, I have multiplied it with 3 times. No, I am not your chemist. How oxygen 7, sir? How oxygen 7 means what? Which 7? I am not able to understand. But I can just tell you. That 7 K2 formula is 7. So each one is to minus 2. So 7 into minus 2. 7 into minus 2 is equal to minus 14. So I don't understand which part you don't understand. If you are talking about the water part of it, I can explain to you that look, there are 4 into 2, 8 waters here, 8 hydrogens here, 3 into 2, 6 hydrogens here. So totally there are 14 hydrogens. Here there are 2. So 14 by 2 is 7. So there have to be 7 waters on the right side. So yeah. How 7H2 I just explained. I just explained. I'll explain again. So K2Cr2O7 plus H2SO4 plus H2C2O4 gives K2SO4 plus Cr2SO4 thrice plus H2O plus CO2. So I want to understand how, or I want to see how I can balance this. In all redox reactions, electron transfers take place. Electron transfer takes place. So the traditional balancing method will not work because that does not take care amounts of electrons transferred. So first we have to balance the electrons. What do you mean by balance electrons? Now charge cannot be created nor destroyed. So we have to equate. Equate number of electrons given by one species to number of electrons taken by another species. So you have to balance number of electrons given by one species to number of electrons taken by another species. And obviously common sense tells that number of electrons taken is equal to number of electrons given. So the number of electrons taken cannot be different from the number of electrons given, right? So in order to answer this, whenever electrons are taken or given, there is going to be change in oxidation number. So I look at the oxidation number of different species on the left side and on the right side. So here I have potassium. So in yesterday's class I explained to you potassium being group 1 element will have the same state, left side, right side. Oxygen, except in peroxide, it will be in the same state, left side, right side. So oxygen. Then hydrogen, if it is an acid, it will be +1. If it's a hydride, it will be -1. So always these are fixed. So there is not going to be any change here. There is no change here. There is no change here. There is no change here. So the only species where there is a change is chromium. That is why I added K2Cr2O7. If I wanted K to change, then I would have added KCl or KNO3, which is a much simpler salt. Okay. Then the other species is H2C2O4. In fact, you have acidified K2Cr2O7. That means already you have mixed these two. So if H2SO4 was the issue, then the reaction you need not have to add this particular species at all. Okay. So understand that in all these cases, memorize that the problem will be or the elements that you have to look at is one is chromium and the other one whatever you are adding. In whatever you are adding, H2 will never, O2 never, so only with C2. Okay. So let me look at the oxidation state of carbon. So I have H2C2O4. 4 oxygens are there, each oxygen is -2, so total is -8. 2 hydrogens are there, in all acids hydrogen is in +1 state, 2 hydrogens are there, so +2. So these 2 carbons are there in the +6 state, I mean together in the +6 state, but carbon is in the +3 state. Okay. So if it helps you, you may write it like this, C2 + 6. Yeah, C2 + 6 is becoming C + 4. So what is going to happen? So because it is C2, let me to put 2. So now it is +8. That means what? It is giving 2 electrons. That means, so this is wrong to write. Okay, so that is why I wrote the 2C. So I have 2C + 3 gives 2C + 4 + 2 electrons. Okay, so the person who is giving has given 2 electrons. Yeah, now let's look at the person who has taken. So from that point of view, we have 2 chromiums and 2 chromiums, each chromium is in the +6 state. So if each chromium is in the +6 state, it has become 2 chromiums in the +3 state. So how can this happen? This can happen because chromium has taken 6 electrons. Yeah, so now the person who has given only 2, but the person who has taken 3, 6. So how is this possible? This is possible if there are 3 of these kind for one person of this kind. So I multiplied this by 3. So what do I have? I'll have 3 C2s. Now because I'm having 3 C2s, I put 3 here. Because I put 3 here, I will put 6 here. So the carbons are balanced. Chromiums are already balanced. Yeah. So now I go to the next one. The next one is sulfate. So here there is 1 sulfate, 3 sulfates. So totally 4 sulfates are there, but here there's only 1. So I put a 4. Yeah. Then now everything is balanced except for the hydrogens. So here there are how much? 4 into 2, 8. 3 into 2, 6. So 8 plus 6 is 14. But here it is H2. So if I put 7, it should be fine. So it's working out. So now this is a complete balanced equation. So given by 1, after that what you wrote, sir? What is hydrogen's oxidation number in hydrides? -1. No, I don't understand this. I can't understand this example means I don't understand. Tell me what you don't understand. No, this is not balancing by ion method. This is balancing by oxidation number method. So you told us to replace KMnO4 and MnO2. How can we get more reactions for homework? But how to write products are okay. That is not a part of this. We'll discuss that. First, let us work with what I am trying to tell you. hydrogen sulfate part again. Hydrogen sulfate part is this, that this side K is balanced, so chromium is balanced. Now totally there are 3 sulfates here. There is 1 sulfate here. Okay, so but on this side I have to have, so totally 3 plus 1 4. So I need 4 sulfates here. So to put 4 sulfates here, I put 4, so that I know it is 4SO4. SO4 sulfate is a group. It works together. That's how you have SO4 here and you have SO4s on this side. This is knowledge that I am giving. So you can't. We have to learn it. We have to memorize it and then keep moving on. Okay, so I wrote 4 here. Once I wrote 4 here, then 4 into 2 8, 3 into 2 6. So 8 plus 6 is equal to 14. So there are 14 hydrogens on the left side. So now I need 14 hydrogens on the right side. In the right side, hydrogen is there only here. Because hydrogen is there here and it is H2, I put 7. So that 7 into 2 will give you 14. Now the number of hydrogens on the left side and on the right side are equal. Given by 1, after that what I wrote, given by one species, 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 given by one species to the number of electrons taken by another species. So if one species is giving some electrons, another species can take only that many. It is your birthday and you have given me you are giving me 2 chocolates. So how many can I take? I can take only 2. If you give me 10, I can take 10. If you give me 20, I can take 20. There is nothing else that I can do beyond that. Okay, so the number of electrons given by one species is equal to the number of electrons taken by another species. Okay. Yeah, I'll explain. First you understand this, then I'll explain. Yeah, balancing is little difficult. That is why you get those kind of questions in your exams. Okay, so focus, then we will be able to get it. So what I'll do now is I will do another example. Okay, so if this is understood, I will take up another example. So I'll take up this example, KMNO4. Yeah, KMNO4 plus H2SO4 plus, let me work with H2S. This will give you K2SO4 plus MnSO4 plus H2O plus sulfur. Okay, sulfur will be formed in this case. So now let me look at the species. So obviously that species which changes its oxidation number on the left side will be manganese and sulfur. So those are the 2 points where I have to look. So here manganese is in the +7 state. Here sulfur is in the -2 state. How do I know? I know hydrogen is +1. So 2 hydrogens, so +2. So by cross multiplication method, I'll know sulfur is in the -2 state. Here manganese is in the +2 state. Here sulfur is in the 0 state. Any element in its natural state will have an oxidation number of 0. So this is the situation. So what will happen? Manganese from the +7 is becoming manganese from +2. How can this happen? This can happen by manganese accepting 5 electrons. Okay, now the same way, if you take this sulfur, so that sulfur is in the -2 state and it is becoming sulfur in the 0 state. How can this happen? This can happen by sulfur giving 2 electrons. Yeah, now you see manganese seems to be taking 5, but sulfur seems to be giving only 2. So this is not possible. So what do? I make this 5 of these happen. Now when 5 of these happen, there are 2 of this happening. So I'll need into 2. Do you understand? So the moment you understand this, I put a 2 here. Why? Because there is a 2. Then I put a 5 here. So the moment I put a 5 here, I will put a 5 here. Okay, now I go ahead, next balancing the sulfates. How many sulfates are there here? 1, and then I'm going to put 2 here, so I have to put 2 here. So there are totally 3 sulfates. So I put 3 sulfates. Then how many hydrogens are there? 3 here, 3 into 2, 6 here, 10 here. So 16. So 16 means what should I do? Here I should put the number 8. So now this is a completely balanced equation. So this is a completely balanced equation. Okay, now let me see. Arey Baba, why did I multiply with 5? I multiplied, I am telling you, now able to understand. Okay. Ritika Shri, why did I multiply with 5? I multiplied with 5 because one person is giving here, sulfur is giving 2 electrons, manganese is taking 5 electrons. So how is this possible? This is not possible, right? I cannot have half an electron. I cannot make sulfur only give 1. Sulfur will give 1, sulfur can give 2. So one sulfur can give 2. I want 5 or multiples of 5. So I multiplied it by 5. So that the LCM of 5 and 2 is 10. So they will now both give 10. So that the number of electrons given is equal to number of electrons taken. My whole idea is this is number of electrons taken. This is number of electrons given, and I am trying to make them equal to each other. This is the fundamental law. Charge cannot be created. Charge cannot be created nor destroyed. So the number given by one is equal to the number given by another. Okay. Now able to understand. Now only you are understanding. What is the name of this method? This is called the oxidation number method. Explain how you write the coefficients. Which coefficient, Baba? Can we do it with another method? We can do, but we have to learn so much more. Yes, sir. Yes, sir. Only, sir. Okay, sir. How can I understand more easily? Only hard work. Hard work. And how H2SO4 came? 3H2SO4 came. How 3H2SO4 came? Yes, I am physics, sir. Okay, how 3H2SO4 came? See, first I put 2 KMnO4. Okay, now see there are 2 potassium, so 2 potassium. There are 2 manganese, so I put 2 manganese. Now look at sulfates. How many sulfates are there here? 2 are there, because 2 sulfates. Here 1 sulfate. So 2 plus 1, totally 3 sulfates. So this side also I should have 3 sulfates. So I put 3 here. Okay, so that's how I put. Yeah. Okay, then. Okay, I will show you second slide. Gopish is trying to write something. I'm not able to see you, Gopish, because it's some problem is coming. So I hope you are able to understand. Okay, so if you are getting it, let us move on. So I hope you are able to understand this. Okay, now I will just do little bit more complication. I will do at least 3 more questions. I will do, don't worry. But before that, I will just teach little and then again I will start doing. Okay, now see, I have KMnO4 plus H2SO4 plus FeSO4. I wrote this reaction yesterday, so I just want to rewrite it. So this will give me K2SO4 plus MnSO4 plus Fe2SO4 3 times plus H2O. Okay, so somebody is asking me, how am I writing K2SO4 like that? Okay, see, I will tell you. I have mugged up. When I was a student your age, my teacher made me memorize K plus all anions of 1 valency 1 all cations of valency 1, cations of valency 2, cations of valency 3. So I have memorized all these things, and because I memorized it correctly that time, I am still able to remember. Okay, actually I am not a chemistry teacher, I am a physics teacher. Yeah, but I am able to remember all these things only because I learnt it correct. So when I was student your age, for the first 1 month or 2 months, my teacher made me write all these things. Okay, my teacher made me write all these things, and yeah, so the impact of that is I remember. Okay, so every day my teacher would make us write so many ions and so many formulas they would make us write. And yeah, so those days, so our teachers would beat us up if we don't do work. They would beat us up, so we were forced to do all that work. Okay, but anyway, my intention of telling you all that is that you have to sit down and read. Today we are not able to force you to memorize all these things, but actually we did all these things in our 10th standard itself. So yeah, so we were forced to memorize all these things. So I know any substance you tell me, mostly I can tell you whether it is a valency 1 or valency 2. So KSO4, suppose I know potassium has a valency 1, I know sulfate has a valency -2. Now I am doing cross multiplication. So it is K2SO4. Okay. Now suppose it was aluminium sulfate. So I have aluminium. Aluminium is +3. SO4 is -2. So now I am cross multiplying. So I will write Al2SO4 3. So this is how I am writing all these species. Okay. And the only way to mastery is perfection. So whenever we used to go to, I can't say this about everyone, but whenever I used to go to a class, I have never gone to a class to sit down and read something that the teacher is telling. I have always gone to a class to see if I know, if I am faster than my teacher, if I can do everything. Yeah, so if I can do everything that my teacher says, I was going to a class purely because of that, which means every class you go prepared and then you go. So find out what the teacher is going to teach and make sure that you know whatever he is going to teach. Okay, so here KMnO4 plus H2SO4 plus FeSO4. FeSO4 will give K2SO4, K2SO4 plus MnSO4, MnSO4 plus Fe2SO4 3 times plus H2O. Okay, so this is the reaction. Yesterday I taught you how to balance it. So again I will tell you, look at manganese and you look at iron. These are the only two species worthy of changing. Nobody else will change. So I have manganese here, which is in the +7 state. Now this is going to become manganese in the +2 state. So how can this happen? This can happen by manganese taking 5 electrons. Then you have iron, Fe. So Fe is in the +2 state. From +2 state, Fe is becoming in the +3 state. How can this happen? By iron giving 1 electron. Yeah. Now here there are 5 electrons. Here there is only 1 electron. So I would like to multiply this by 5. Okay. Now suppose I put 5 here. I have to put 5 by 2 here, which is not possible because whenever you balance, you have to have integral numbers. So what will you do? You will multiply the whole thing by 2. So I put a 2 here and I put a 10 here and I put a 5 here. Now that will work out. Okay. So let me just go reverse. Yeah. So I put a 5 here and I put a 10 here and I put a 2 here. So now basic things are all done. Okay, because I put a 2 here, I have to put a 2 here. So 2 manganese, 2 potassium, taken care. Now count the sulfate. How many sulfates are there here? Here 5 into 3, 15, 2 into 1, 15 to 17 plus 1, 18. Here 10 sulfates are there. So 8 sulfates are required. So 8 sulfates come here. Yeah. Now 1 8 comes here. You have 8 into 2, 16. 16. So here you should get another 8. Yeah. So now this is fully balanced. This is fully balanced. So now first, are you able to understand this? I'll be back. Why 2 KMnO4? I just now explained. How 5 by 2? Hey, instead of asking me questions, please ask yourself. Yeah, please don't ask me questions. You please put yourself. So you put 5 here. So what does this 5 mean? 5 Fe2 plus. Okay, so put 5 here. If you put 5 here, how many will you put on this side? There are, each one has 2 Fe2. So how many will you put here? See, before you ask me questions, please ask yourself also some questions. Tell me, how many can you put here? 5 here already. Fe2 is there. So how many will you put here? You have to put 5 by 2 because each one has 2. But you can't have half a molecule. Not possible. So you have to have integral number. So I have to put 5 here. If I have to put 5 here, I have to put 10 here. That means this whole thing has to be multiplied by 2. Because this is multiplied by 2, this will also be multiplied by 2. Okay. So please don't ask only me questions. You ask your brain also some questions. No, it is not 17 SO4. How do we? Yes. No, I'm not going to get any diversion from anything. Test and all, please don't ask me. How you put 2 KMnO4? Again, apply common sense. No, I multiplied this by 2. So what do you mean multiplying by 2? How many manganese should be there? 2 manganese should be there. So how will you get 2 manganese? Only if you have 2 KMnO4, you can get 2 manganese. See, the reason why you guys are asking all these questions is because you have done no work. You are only trying to understand based on the work that I am doing. So you are facing this difficulty. Please pick up your pen. Instead of copying from what I have written here, please try to write something by yourself. Only then you will understand. Otherwise, you will keep asking all these questions every time. Okay, so here it is MnSO4 plus Fe2SO4 3 times plus H2O. So now here Fe is in the +2 state. It has moved to Fe in the +3 state by taking electron. Manganese is in the +7 state. It is taking 5 electrons to make manganese +2. Yeah, now you please work from here. Don't ask me any questions. I have told you the chemistry behind it. The rest is calculations which you should know. So please try to find out how you can work from here. You know the concept that number of electrons given is equal to taken. So please try to work it out. So common sense will tell you, you have to multiply this by 5. So please multiply this by 5. What does it mean? It means that you will have 5 Fe2 plus. So here you put 5. Now you please use your common sense and tell me what number will you put here. I put 5 here. What number will you put here? Common sense, because it is Fe2. You have to put 5 by 2. That means you have 5.5 molecules of Fe2SO4 3. You cannot have half molecule. You have to have only integral number. So next, again apply common sense and tell what do you want to do with it. So you want to multiply the whole thing with 2 so that this will vanish. Right? So here you have 1, so it became 2. So here you had 5, so it became 10. Yeah. Now because there are 2 manganese here, there have to be 2. Already there are 2 here, so there is no problem. Now count how many sulfates are there. 5 into 3. Each molecule has 3 sulfates. So 5 molecules will have 15. Here 2. Here 1. So total is not 17. Total is 18. There are 2 manganese. 2 manganese. So totally there are 18. So if there are 18, there are 10 here, 10 into this. So you have to have 8 molecules of this. Only then you will get 18. Now 8 into 2 is 16. So only if you put 8 here, you will get 16 hydrogens. Now potassiums are balanced, manganese is balanced, everything is balanced. So this is what a balanced chemical equation is. Okay. I repeat again, you guys are having problems because you are not working with your hand. You are not working. You are copying. If you are copying, many of you are first not even writing, you are just listening. Okay, by listening, you can't learn all these things. The only way to learn it is by doing. So please use your notebooks, pen, only then you will learn. Otherwise, you won't learn. You will again and again keep asking the same question. Okay, so please understand certain logics. Number one, you can't have half molecules. Okay, you can have only integral number of molecules. Fraction molecules not possible. So 5.5 is 2.5. 2.5 is 2 molecules is possible. Half molecule is not possible. Okay, so the only next thing that you can do is you can go up to 5 molecules, because I can't give another half to it and make it 3. So I can multiply it by 2, saying that there are 2 of this kind. That means there will be 5 molecules. Okay, so when I say 2MnSO4, this 2 stands for 2 and 2 stands for this also. So it is 2 sulfates and 2 manganese. 2MnSO4 means MnSO4 and another MnSO4. So now how many manganese are there? 2. How many sulfates are there? 2. Okay, so this is what we have to understand. Yeah, so okay. What is the difference between Fe and Fe2? Yeah, one is charged, one is not charged. I mean, I don't understand the question. Yes. Yes. I hope now you are able to get why I put 2. No, then that whoever taught you, that was wrong. If somebody is taught you partial balancing, it is wrong. No reaction can be partially balanced with fractions. Even books make mistakes. In your NCERT book, there are many mistakes. Okay, so if I am writing a reaction like this, H2 plus half O2 gives H2O. Okay, and then I can say that this is happening many times. This is correct. Even though I have written half O2 here. Okay, this is correct. Yeah, but suppose I tell you that H2 plus O2 forms H2O, balance it. You have to balance it this way. You cannot balance a reaction saying H2 plus half O2 gives me H2O. No, this kind of balancing is wrong. But in some context, I can write like this and explain what it is. That doesn't mean I have balanced it this way. So we have to check what exactly is there in the book. Okay, but balancing the equation can be done only this way, and you can't do fractional balancing. No, half O2, 2 won't be cancelled. There is a big difference between half O2 and O. H2 plus O gives you H2O, and H2 plus half O2 gives you H2O. There is a difference between them. Here O is atomic oxygen. So it will, reaction will occur. This is half oxygen is half a molecule. Half a molecule cannot exist. Cannot exist. Definition of a molecule. What is the definition of a molecule? A molecule is the smallest particle of any substance which has independent existence. So half O2 doesn't have independent existence, so it doesn't exist. So you can't write it. That's why it is wrong. Okay. So H2 plus O gives you H2O is okay, because then I'll understand you are talking about atomic oxygen. But half O2, 2 will not get cancelled, because this is half a molecule of oxygen. So there is a difference between them. Science is a very precise subject. Yeah, so gypsum reaction. Yeah, gypsum reaction, you have something like, I mean, I don't know what gypsum is, but I think it is CaSO4 dot half H2O. The reason why they write it like this is because there are 2 gypsums. Okay, so there are 2 gypsums with 1 water molecule. Now they are taking a shortcut and they are writing it as CaSO4 dot half H2O. If you ask me, this is wrong. In many books they won't write it. No foreign author book will write this. But in India, anybody can write a book and anybody can publish it. I mean, I can publish in the internet, I can publish sun rises in the west. People can read it, and if I'm an influential person, it can come in the CBSE textbooks also. Many such things are there in the CBSE textbooks. Wrong facts about many things are there. Okay, so anyway, let's not get into all that. I am your teacher. Listen to the teacher. You don't write fractions. Okay, so yeah. Nascent oxygen and atomic oxygen. Nascent oxygen is more reactive. Nascent oxygen is just born oxygen. Nascent oxygen, like I was telling you yesterday, this is oxygen molecule. This is oxygen atom. This is nascent oxygen. Nascent oxygen is just produced oxygen. This is highly reactive, much more reactive than these two. Okay. Anyway, forget it. This is not a part of what we have to be learning. So if you have direct questions on that, I'll answer. Yeah, I will show you the 5th slide. So show 4th slide. 4th slide. What is the difference? Not. Yeah. So let's move. 4th slide is here. You may write down. Already time just flies. We started at 9:40. Now it's already 10:30. Yeah, this is the 5th slide. I've still not come to what actually I want to teach you. Okay, so let's move on. So let me rewrite again. KMnO4. You see, as a teacher also, I am writing the same thing 20 times. But as a student, you guys are not writing. Only if you write, you will learn. Otherwise, you won't learn. If you copy, you'll all the time be copying. So please try to learn. Write by yourself. Okay, KMnO4 plus H2SO4 plus FeSO4 gives K2SO4 plus MnSO4 plus Fe2SO4 3 times plus H2O. Okay. Now I am telling you, see, all these things are in solution. Solution means they are all in water. They are dissolved in water. When you take KMnO4 and you dissolve it in water, it gets converted to K plus MnO4 minus. That means the 2 ions break. The positive ions go separate, the negative ions go separate. Okay. Similarly, if you take H2SO4, it breaks to form H plus SO4 2 minus. Similarly, if you take FeSO4, this also breaks to form Fe plus 2 plus SO4 2 minus. Okay, water has this property. Water has this property. Any ion, any electrovalent compound which is put into it, if it dissolves, it will break the salt or break the compound into its ions. Okay, so if all these things are, these reactions will take place only in water. Okay, so if all these species are there, then what are the species which is actually there in water? So I'll have K plus MnO4 minus plus H plus SO4 2 minus plus Fe2 plus SO4 2 minus. Do you understand this? All this is in 10th standard, 8th standard. I have to now ask your teachers, Blossom School, I have to tell you to give minus marks for you. Electrovalent compound is a compound formed by the attraction of a positive ion and a negative ion. Every lesson in chemistry has numericals. Okay. If we apply the same in exams with fraction equation, mark will be cut. Absolutely, it will be cut. What is Rahul? What is electrostatic force? Rahul, you have to go back to 10th. Then you have to come back. Only then it will work out. Otherwise, it won't work out. Electrostatic force is a force between a positive ion and negative ion. Those things are not required now. You please learn what is required from that is more than enough. Okay. So all that I am telling you is KMnO4 will break into K plus MnO4. So these are the compounds and they are broken into their respective positive ions and negative ions. So this is the positive ion, negative ion, positive, negatives, and so on. So the left side of the equation can be written this way. Okay. Now, once the left side of the equation is written this way, the right side can be written this way. K plus SO4 2 minus plus Mn2 plus SO4 2 minus, again already I have put plus Fe3 plus, already SO4 is there, plus H2O. H2O is neutral, so I can't write about it in any way. Do you understand this? Do you understand the left side and do you understand the right side? Yeah. So now if you understand the left side and if you understand the right side, I can take away K plus because the same things are there on both the sides. So it is always in the same form. Similarly, I can take away SO4 and all these SO4s. They are all in the same form. No change. No change. Yeah. So I can now rewrite the equation as MnO4 minus plus Fe3 plus forms Mn2 plus Fe3 plus of course H2O is there here, and this reaction takes place in the presence of H plus. Yeah. Now such a reaction which has only those species which change their character as the reaction proceeds is called a ionic equation. This is an ionic equation representing redox. What did I do? I removed those ions which are in the same form on the left side and right side. Those ions are called the spectator ions. Spectator ions. These spectator ions do not undergo any change. These spectator ions do not undergo any change. Instead, they just observe the reaction taking place. Okay, so this is what is referred to as a ionic equation. Okay, my class time is over. So those of you who are having some doubts, here is my number. Message me, I'll answer. Okay, this is my number. Please message me. I will answer. 9947 99776. Oh, 6 minutes is left. Okay. Yeah. So I am telling you, spectator ions are those ions which do not participate in the reaction. They are just present. So on the left side here you have K plus, on the right side also it is K plus, there is no change in it. So spectator ions are those ions which do not change. So the way they are on the left side, the same way they are there on the right side. So we can't even say that they have participated in the reaction. Okay. Ferrous sulfate consists of two species. One species is Fe2 plus and one species is SO4 2 minus. So when Fe2 plus and SO4 2 minus come together, ferrous sulfate is formed. Sulfate ions on the left side and right side are the same. They don't undergo any change. So they are spectator ions. Spectator ions are those ions which do not undergo any change. Okay. How Fe2 plus becomes Fe3 plus? That is a reaction that is taking place. Redox means what? Reduction, oxidation. So Fe2 plus is becoming Fe3 plus by giving an electron. That is what we have been telling all the while. We have been telling that only. So now if you are asking me how it becomes, then what can I say? Here, Fe2 plus is becoming Fe3 plus by giving an electron. Yeah, K is a spectator ion. How LHS has Fe3 plus? Arey Baba, that is redox. What do you mean by redox then? Redox means what? Redox means a reaction where there is an electron transfer taking place. Fe doesn't have the same ionic number. Fe's numbers are different. On left side it is +2, right side it is +3. So it is different. This technique cannot be used in the absence of water because these reactions don't take place in the absence of water. Half a molecule is not equal to one atom. Half a molecule is not equal to one atom. Half a molecule is not. It depends. No, this is +2. This is 2 plus, Fe2 plus, and this is Fe3 plus. So I have not written the same thing. Okay, here that you have to change. That's what I'm saying. All of you are only seeing what I have written. You are not trying to work it out. So this is what I have written here. 2 plus. Clearly I have written 2 plus. This side it is 3 plus. Okay. So this is an ionic equation. So for every reaction, I can write an ionic equation of this kind. Suppose I have another equation, KMnO4 plus H2SO4 plus HCl. So this will give KCl plus MnCl2 plus I'm sorry, this will give KMnO4 plus H2SO4 plus HCl gives K2SO4 plus MnSO4 plus H2O plus Cl2. So left side species will be K plus MnO4 minus plus H plus SO4 2 minus plus H plus Cl minus gives K plus SO4 2 minus plus here manganese. This is the name of the formula of the compound. So if this is 2, this will also be 2. So it is Mn2 plus SO4 2 minus plus H2O plus Cl2. Now sulfates are there on both the sides. Potassium is there on both the sides. Yeah, so that is it. So the equation now becomes MnO4 minus plus Cl minus plus H plus becomes Mn2 plus H2O plus Cl2. So this is the ionic equation representing this. What are the species we have removed? We have removed K plus, SO4 2 minus. So these are the only species we have removed. So these are called the spectator ions. Spectator ions refer to those ions which do not undergo any change as the reaction proceeds. They remain the same way on the left side and on the right side. They remain the same way. So such ions are referred to as the spectator ions. Such a reaction is called a ionic reaction because it has mostly ions which are reacting. Such a reaction is called a ionic reaction. Okay, so you have spectator ions and you have ionic reaction. Yeah, you can put 2H plus, there is no problem. We have not balanced it. Once we learn to balance it, next we have to learn to balance ionic equation. So we don't know how to balance it. Yes, everywhere there is a burning, there is a chemical reaction for it. When you buy that sparklers, the reaction taking place is Mg plus O2 gives you MgO, sulfur plus O2 gives SO2, carbon plus O2 gives CO2. So these are the reactions taking place when you buy sparklers and when you burn. When you burn sparklers, so this is the reaction which is taking place. Okay. Yeah. Okay. Then, yeah, I know Tamil, but I won't speak in Tamil. Is this a balancing method? No, a balancing method we will learn in next class. H2O is a neutral molecule. It is not written that way as H plus and OH2 because it's a neutral molecule. All the others, but you can write it if you want to write H2O, you can write it as H plus OH minus. We can write like that. But yeah, it's not written because water is neutral and it forms water. It doesn't, in water you won't find this. But if you take NaCl and if you put it in water, you will find only NaCl. You will not find NaCl. But in water, you will find water. So water is not broken, everything else is broken. Anything else when added to water breaks into its respective ions. Water doesn't breaks into its respective ions. Okay. Yeah. Hey, all these questions you message me. I gave you my number, you message me. Yes, Kambi Matapu, red color is by lead combining with oxygen. No, red color is because of potassium salts. Potassium salts, then again chromium, red color is because of potassium, not potassium. Red color is because of calcium. Yes, anybody wants to know anything more can message me. Yeah. This is first slide. Second slide. Red color is because of calcium. Yellow color is because of sodium. Then green, blue is because of copper. Apple green is because of barium. Lilac color, violet color is because of potassium. Okay. So this is the fourth slide. Fifth slide. Sixth. Seventh. Next one. Next one. Okay. So this is how we are going. Okay. Yeah. So here is my number. Okay. Bye. Adishri, I don't know what you're saying. You're talking about manganese. We will talk, but manganese is very reactive. Manganese is very reactive. Anyway, next class we will talk. Okay, here is first slide. Okay, yeah, bye.